think in a blind taste test, you could taste the difference between the Fruit Loop colors.
Yes.
No, because they're the same color.
Do you think in a blind taste test you could taste the difference between Skittles?
Yes.
No.
Skittles are different flavors.
I always eat like 8
They
at a
taste
time.
all the
So
same.
you don't know what they taste like?
Oh,
me
Skittles are
too.
exactly the same. No, they're not.
So, eventually you'll have the chance to do science fair, and those are some fun experiments that you can do with science fair. So, we are recording, which means when I finally move on, you can always access the answer key through the class video, right? But unless you have questions about, like, I got that wrong, we're not going to spend too long on this, because we need to, like, wrap up and formalize and make sure that we're all good on graphing lines. Lucy?
Yeah. Oh, yeah, can you go to 43?
Yep. Wait, what? 53?
43.
43.
Yeah, 53. 53.
I was confused for a moment. Well, I'm confused lots of moments, but... Are we missing it? Are we missing it? Or you
Oh,
got it?
sorry, I was putting stuff on my...
You're okay, but are you good with the answers and everything?
On 4.5, I should probably do the answers. I spaced out. I really got caught. Oh, wait, no, I already did that yesterday.
Yeah. You need to do this one, so it looks like.
Oh, yeah, I have the graph paper.
Okay, sweet. Yeah, guys, if you are running out of space on homework paper, graph paper, staple it, tape it. I don't care how you connect it. Just connect it with your papers. All right, if you don't have graph paper, get graph paper. If you aren't on Desmos yet, get on Desmos. But when you get on Desmos, and guys, I find it funny that, like, you guys Google everything. Just type in Desmos.com. Like, because some people earlier Googled Desmos, and then they ended up, like, on the wrong part. It, like, jumped to one of these other pages. You want the main Desmos page and just click Graphing Calculator. And then we are all going to type in, just to experiment with some things, y equals mx plus b. And notice the options that then pop up. And guys, notice that you can save your graphs. So if I go to save this graph, I can say, like, playing with slope / y-intercept. So I'm going to click all on those sliders. And I'm also going to make a graph of y equals x. Now, y equals x is really y equals what x? How many x? 1, right? So whether I put a 1 there or not doesn't matter. Right now, m is 1. But if I, like, slide my slider, I can see what happens to my line as I move m. If I slide my slider for b, what did we call b yesterday? It's in the title of my graph.
The slope?
Oh, yeah,
The y-intercept. So if I slide my b, it changes my y-intercept. Right, which effectively translates us up or down. And Mikey, I wanted to save it and share it with me, but Mikey in the other class has already started, like, making some art in here because he got totally done with the Desmos activity yesterday. So what Mikey started playing with is stuff like, well, what if I graph y equals 2x on the same graph? What if I graph y equals 3x on the same graph? Or y equals 4x? And the more we play with this, if you long hold over here, like long click, you can change colors, you can change, like, textures of whether it's dotted or dashed. You can do all kinds of stuff in Desmos. You are correct.
You can also hear graphs.
Yes.
It's a ton of cool art you can find if you Google this.
Have we not looked at that in this class yet?
No.
Wait.
So if you scroll down on this main page, the main Desmos page, scroll down, you can see all the finalists. So about your age, right? 13 or 14. From California.
No.
This is all made just by graphing lines.
No, Sean. No, Sean.
That's graphing.
Oh, what? Wait, no.
What? Okay, guys, you can't say there's no way when it's like the evidence is right here. So the folders are each individual parts of the graph. So this is very complicated, right? But this is what
Complicated in an understatement.
the different layers that we can turn on and off, but I very quickly like break it, right? Because I don't know what I'm doing. So that's when we go back and we say, all right, let's look at a different one.
Ages 19 is Ohio.
Is Ohio? Ooh.
Oh my god. They made a ski slope. Oh. They made it's a pond.
Ha, ha, ski, slope, but Nick.
So, look at that one.
The one thing that I think
Shadows,
is really strange is try y equals x divided by y.
Oh yeah. That's how you make curves.
X
Oh, I think I did
divided
that
by y.
before. Yeah, that's equal.
Now wait, what if I want to point it the other way? I can just do this.
What if you do X?
And now, what if I start tweaking the number in front of this?
How do you do the square?
How do you do what?
How do you do the square?
What do you mean the square?
Like X squared.
Oh, so on your keyboard, the caret is how you get to a power. So on your keyboard, if you're typing and you go shift caret, that's how it bumps up to a power. And also, guys, there's a keyboard here in Desmos that can pop up. So you can also play with what happens if I do square root of x. Because square root of x can't go negative, it actually cuts off the graph for you. Guys, you can turn graphs on and off by clicking the left little button. Turns the graph on and off. Now here's the problem. I can't pause your Desmos now because you're just like in free play. If you want to save, you got to be logged in, right? You can log in with Google. It's your school account that you would want to save it with. But for now, let's go do a little bit of lesson. I know, I'm sorry, heartbreak. So, all of that to help us. Hey, everyone go halfway. I'll give you one more minute, then go halfway down with your screen. Then we need to look at 417. Okay, I'll give you one more minute to play.
How do you adjust the
Play with it. Guys, I am not going to give you answers when you come and say, how do I? Just play with it. Just experiment. Or Google it.
Wow.
Make a math pun. I have a really good math joke, but I'm too squared to tell it.
How did you get it? How did you get that on square, like the square root?
Clicking the keyboard that pops up. There's a keyboard icon. Like Desmos has a keyboard. That's x cubed, right?
I mean X3.
X to the third power, which is actually x cubed.
Yeah, I mean X cubed into curve.
Now that your hands are off your keyboard, let's do some other math. So, guys, either shut your screen halfway or have enough self-control. On your 417, right, you got two different problems, A and B. You're going to need your graph paper to do this. Bless you. So, we can look at this graph and actually pretty much figure out the rule just from this much of the graph. Right, because what we practiced on the homework last night is drawing those growth triangles. So if I draw a growth triangle, I could either stop it right there, or because I want to look a little bigger and like be able to see it a bit nicer, I can make my triangle over 2, and then up. So is it 8 divided by 2? Because I stopped at 8?
No.
What is it, kid?
It's 6 divided by 2.
Because, you want to explain it?
Sure. Yeah. Okay.
I know I was pointing the wrong way, but
Yeah. So it would be 8 divided by 2, except you start 2 above 0, so you would subtract 2 from 8 to get 6 divided by 2.
I would just go ahead and draw the bigger one to show the work that we're doing. So to calculate our slope, our m, and I would write this if I was you, it's not just y over x. That only works. There you go. That's not miscellaneous. It's like the furthest thing from miscellaneous. It is delta y over delta x because this graph is not what? What is this graph not doing that a lot of the other graphs that we did, like in Desmos, did do?
It doesn't intercept with the origin.
It does not intercept with the origin, which means it is not proportional. So, then talk with your teammate about what does the equation become that describes that line. You probably only need like a minute, so chat with each other.
So it's, yeah. 3m plus.
So Nick, what do you think the equation is going to become? I know they're all kind of finishing, but they're still arguing.
So since if you make like if you divide both the things,
Yep.
6 into then you get 3. So that's m. So y equals 3x plus 2, which is the y-intercept.
Yeah. Now's the fun part. On your graph paper, draw this pattern. So what does this pattern start with?
2.
2. So our first, our first figure or zero figure?
0.
Our zero figure is going to have 2. And guys, pro tip, I would maybe number that this relates to 64A. So 64A would probably be a really good thing to put on your paper first. And I would write out y equals 3x plus 2 to remind yourself of what we're doing and why. And then we can draw, okay, figure 0. I don't know, however you want to draw 2 tiles.
There's not much freedom there.
Well, I mean, you could, it could have been that. It could have been diagonal from each other. It could have been side to side from each other.
It'd be separate.
I mean, I guess it might make it harder to look at. So to get to figure 1, what do I need to do? Add 3 tiles. Do it however you want. Do a couple of these, and I'll put them under the dot camera if you think, if you would like to share yours, if you think yours is, clever or creative. Or...
Should we highlight the ones we add?
That's up to you. These are your notes for you.
Is it okay if I just do number now?
A what? So a table? Nope, that is not what I asked you to do. Because we need to be able to visually see what we're doing. So that's the next thing we're going to do. Yes, because that's the next thing we're going to do. So Sam asked, can I do this instead? And not instead, but you can do this also if we make an XY table. And really, X is our figure number, Y is our amount of tiles. Right, so figure 0 had 2, figure 1 is going to have 5, figure 2 is going to have 8, figure 3. Sure, Soph, come on up.
Can I also show mine?
Sure.
Okay, can I show mine?
Sure. Guys, I don't really, I'm not Do I have a reason to say no? I mean, as long as it's right and it's not going to confuse people.
I'm physically capable of
Is it
showing
camera?
my project.
Oh my
I
gosh,
wasn't going to do the teacher thing, but it's whatever's on there too. So you can-
it's a paper.
So we're doing like an arm up, and then like a tail outward, or however we want to call it. Of like, there's like a branch heading up towards the edge of the paper.
Admire my amazing squares.
Yeah, and then it kind of falls off the edge of the paper. But so 1, 2, 3, right? And then 1, 2, 3, 1, 2, 3. Yeah, that would work. I don't know. Even with my imagination, I don't quite know what I could imagine that is.
It's a giraffe.
Oh,
It's
it
a dino.
obviously is a giraffe. Okay,
No,
well,
it's a dino.
it's a giraffe missing its tail.
No,
lobes. That's
no.
sad.
It's one of those things that you sit on at the playground. You rock back and forth, you know?
Like a seesaw.
No,
Oh,
like,
the little springy thing.
yeah. The one
There's
with
one of
the-
those over at the rally point.
But it's like for a giant. Or something.
Guys, our rally point is the playground. Lucy,
Yeah.
come on up.
Wait, can I put my head under it?
Yeah, I can't wait till you have another
You're not
rally
gonna
point
fit.
meetup.
Please?
No, we're filming.
Oh, please.
No, we're recording. It's gonna go on YouTube. Let's not.
Close your already showed
It's like a
me.
FERPA violation, like student privacy stuff.
Well, my hand's out on YouTube, so.
Oh no. Someday Soph becomes a famous hand model because somebody spotted her hand on. That's a reference to Seinfeld that none of you get. Okay, what's up, Lucy? Talk to us about what you got going on here.
This is the 2, so it's like just the 1, 2, it's diagonal. And then I add 3 by doing it diagonally 2, like under the 2. And then for 2, I add these, and then it's going like in the opposite way, so it's like kind of mirroring. And then this, so it kind of goes like up and down with the figure numbers.
I'm finishing mine up and then I'm gonna show
So yeah.
So take a second to finish up that one, and we'll show whatever. All of these hands probably just want to show. I don't care, guys. Go up. Like, just don't fight. Go one at a time. So, like, if you want to show your stuff, I do not care. It is fine.
Lucy's short track second.
Hey, if you have to decide who goes first, just rock, paper, scissors. I don't care. Just go.
Yeah, the
Just
last
go.
one.
Tie your shoe.
No.
Yes.
So,
Well, if he wants to
mine,
share his
you
thing.
just kind of add one here, and add one here. I highlighted it so you can see where I'm adding.
Yeah, so you're kind of making like
Okay.
a 3-pointed ninja star or something. Like, it's just kind of like.
Wait, do we leave these?
No, we're gonna do another one. All right, Colin, what you got?
Mine's just diagonal. Like that guy and that guy.
I just want my
And then
copy.
I just added 3 each side.
Yeah, and Colin used some highlighting to help indicate what's going on. All right, go ahead and let Katie. So Noah, you don't want to anymore. Okay.
So, I have my starting 2, and then I have 3 that get added on to the top and the sides.
Oh, it's a cup stack.
No, it's a growing Christmas tree.
Oh, it's a great. Oh, it's not even Halloween yet, sir. It
I
is still
know.
spooky season.
I know. That was part.
It is a jack o'
You
lantern.
can't start talking about Christmas when it's not even Halloween.
I wish
I mean, we can. All right, 2 more, and then we're doing the next one.
So here we have the very intelligent thing.
Hey, Bryson, a classmate is presenting.
Yes.
Yeah, so adding on the little like right angle corner, right?
Yeah.
Stacking that sort of on top, off to the side. Love it. All right, Noah, real quick, and then we're gonna move on and do part B.
Okay, so this side came from the darkest depths.
Hey, we're getting disrespectful, and that's where I draw the line. No,
so
go
like
ahead.
this came from like the darkest depths of my mind.
Uh-oh.
Can you zoom out a little bit?
cool.
So I zoom out a little bit.
I
Oh,
like
you just
that.
left. Hit manual zoom out.
It's
Dang.
very satisfying.
Well, this is well, yeah, this is my thing. So it starts out with like 2 little dudes, and then it adds 1, 2, and then 3. Then it adds 1, 2, and then 3. Then it adds 1. I forgot to add 2 there. Do you have a pencil?
Nope. No, you're good, but
Okay.
go fix it
Then
at your
it adds
desk.
1.
Yeah.
There, imagine my fingers. There are squares. 1,
Well, then that's
2,
So next time
And
we
then
gotta verify
3.
that we're totally right before we come up,
and
right?
then
All good though. Mistakes, you're fine. Mistakes allow us to get to those right answers. Throw it on there. You can go ahead and look at B if
I
you want.
was wanting to do some art, so I went a little bit over. But if you see right here, I made that.
Very cool. It's messing with me that I don't see the squares. Like, you have the shading, but not the squares. That's screwing with my brain, but I think it's pretty cool.
Mine's the most creative thing on the planet.
All right, last one for real.
It's so
Mason's last one till B.
It's so creative.
Ah, I was waiting for someone to just do that.
It's so creative. It was the most creative thing on the planet.
All right, so for
Oh
B,
Minus 2.
for B, it was just a big long line. For B, for B,
We don't have a
Furby.
Furby. Furby or not Furby?
Chaos, I'm sorry.
That is Furby.
We protest Furby. It's the furry of we protest Furby. Guys, we protest Furby.
Guys, I didn't mean to cause chaos.
Sure. Sure you did, Noah. Sure.
ruler for good measure. They were saying for good measure, like, you know, the phrase, but I for good measure, like with a ruler. What is happening in B? I don't have my random card, so I'll just take Isaac?
Can I just say the rule?
No, tell me how you get there.
So basically, you know that since this figure is 0, 14 is the constant, I think. And then you subtract, and then once you get up of figure 1, it takes away 3. X. Yeah.
The y-intercept, which is also known as the B.
Yeah.
The minus 3 is what's also known as the M. So Isaac, what is the rule?
Negative 3x plus 14.
Negative 3x plus 14. So if we were to draw a graph, hold up, a graph of this, we would draw our xy axes. So draw some xy axes. We need to make our y-interceptor where we start 13, so I hope I've made this 13 tall. 14. Oh yeah, because 3 is the change. 1, 2, 3, 4, 5. Cool, just barely. So we start at 14.
Can I just like do the graph on that?
Hey, people that are still on your computers, if you choose not to do this, I'm going to play you a sad song on a tiny violin when you come complaining to me that you don't know how to do this. So we start at 14, but then it tells us as we move. Now, I'm assuming, but I should probably write, that we're doing a 1-to-1 scale. Always give an indication of your scale. Now, the 14 tells me that my scale was 1-to-1 because that's 14 boxes. But still, make your life easier and make other people's lives easier, like the guy grading your papers. Just show the scale. So then every time we bump over 1x, what happens?
-3.
We go down by 3, which if I want to draw a growth triangle to show that, what, math has a soundtrack, man. There's a genre of music called math rock. I'm not joking.
Yeah, I've heard about it.
At all.
When Rin does math, she does sound effects.
That's because math has sound effects.
Every time I made a dot yesterday, because me and Soph worked on homework together, I just went shh, shh. And she was like, so we put it right here, then we go shh, 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 shh. I'm like,
I think I listened to like a podcast about nerdcore music.
Oh, yeah. So then, if you would like to draw pictures of this one, you may.
That's very aesthetically pleasing.
Pictures of it?
Guys, no joke. This is math rock.
I want to hear it. Wait, did you pause the video?
Nah, I mean, sure, I probably should. For enough math, and everything is math. Oh, yeah, here we go. So you don't have this on your worksheet, but that's okay, because you have graph paper out. So, you are shown figure 2, 3, and 4, but wait, this is different. So if you're still on your computer, maybe get off your computer. What we want to know is which figure is gonna have 79 tiles. work with your partner to try to figure out how we could deal with this problem.
So you're adding like 4 tiles?
Write down whatever you think you need to.
Okay, so we have 11. Yeah, so 11. And then he said 4.
Yeah, that's there on that playlist.
So,
Did you just look it up or what? Yeah.
I'm not finding the
No, I don't have time. Sorry. I know it's really fun. You guys can show each other.
Plug in all the
So,
numbers.
love what you
Wait,
have,
so-
but I need you working on this one because this is the next standard that I gotta make sure we learn.
Okay, so we have accessory 2. And
So, what do you see? Okay, so that's, I mean, I don't think you're really malfunctioning that bad.
Okay, so if we use
So
the
aspiration,
thing
so if we undo that twice, since we're at figure 2, we undo it twice, what do we still have?
Alright, so it's.
Talk with Noah, he said his brain was slightly malfunctioning, he might need your help. Or turn around and talk to Liam.
Wait, I need to check this algebraic expression.
Get 60, get to 71, which takes 15 figures, plus 2 figures, 2 fours.
Is there an easier way to get to where you're going?
In my brain,
4x plus 3. It's that easy. It's that simple.
Lucy! Potty mouth over here.
Oh my
She's
god!
right to my face, too. She goes, it's that! Good.
And then I said simple.
It's
Alright,
more
Lucy, fine. Talk us through it.
Yeah, Lucy, go away.
You said the bad word. Hey, alright, come back.
Okay, I can
Come
do
back.
it though.
Come back. Lucy, talk us through.
So, I did.
No,
Oh, I did. Okay. So, I noticed that every time you add a figure, there's 4 added in like the L thingy. So like if so in figure 2 there's 2 L's. So that means that yeah, there's 2 like X's which is being added plus the 3 that was already there in figure 0. So
I was
that-
using, if I just like wipe those out, that is figure 0.
yeah, so
Oh,
it would
okay.
be 3 plus 2 or 3 plus 4x because you multiply 4 by like the figure number because there's 8 like tiles added onto the 3 in figure 2 because 2 plus 4 or no 2 times 4 is 8. So yeah.
Either way we write it, 3 plus 4x or 4x plus 3, doesn't matter, right? Because addition is commutative. We can swap that order. Now, what we like better, I don't know why. And guys, I'm being serious. We like that form better that gives you the slope first, but what mentally makes sense if I have to go graph it is start at 3 and then show the growth. So it's up to you how you write it, but most of us, like most mathematicians, most teachers or classes, we're going to write it in the mx plus b form. That's just what we default to. So wait, so Lucy, Bryson was over here explaining like a deep dive of like how to get to his
But it's
answer.
not a deep
And-
dive.
Well,
It
but
was
you
just-
added like 15 and then 2 more and then and I got
It's
lost.
just a multiplication.
Well, okay, you just is halfway to a bad word. But Lucy, what do you want to do to figure out 79 tiles?
Oh, so I just subtracted 3 from 79. So I did 79 minus 3, which equals 76. And I used the handy calculator to divide 76 divided by 4, which I found out equals 19. So the figure number would be 19,
I did it in my
according to my calculations.
Guys, once you spend a little bit of time getting comfortable with doing algebra with equations like y equals mx plus b equations, I'm not going to say it's E word, but it flows, right? Because what Lucy said was 79 is the y, because the y is the tiles, right? So if 79 is the tiles, we math word substitute, right? We substitute in, and then we do the algebra. Questions? What'd you say? Well, it is a math word. Oh, I see what you did. We call them guest teachers now. If I tell you that the x-intercept. So wait.
It just starts at 2. It's
Well, no, but not y-intercept. The x-intercept is 2.
That's just
it could
what
just like be the 2 on the x-intercept.
But,
Why?
guys, hold on. Because I think we're misunderstanding what this is telling us. If the x... Yeah, the x-intercept is 2. What Zach is saying up here is it starts here. Not like, we're not talking about starts there. And then they say, okay, and the pattern grows by 4. So, all right, we could go up 4 over 1, right, to our next point. But, so what do we know about the y-intercept inherently if we start at x equals 4? It's negative, right? It's going to be down there. Now, if I'm going up 4 over 1, I'm actually going to come back to my graph paper, right? Up 4 over 1 from x equals 2, they said. Guys, draw this out real quick on your paper. X-intercept of 2. Guys, I still have like 5 minutes. We've got plenty of time. X-intercept of 2, and they said a growth of 4, so I can make my growth triangle right there. I bet you can work your way back to the y-intercept to figure out this equation. Take a minute, maybe 90 seconds with you and your partner and try to figure this out.
Okay, Leo.
Is there a better way?
Well, okay, I like that question. Sorry, I was shushing you just because I figured you were just going to try to jump right to it. Talk to me. What do you mean? Is there a better way?
Yes, Leo. Okay.
What
What
is
should
your-
we do, Leo?
So what we do is the slope is where
Yeah, that is the way.
oh wait, that's 4. The slope's 4.
I mean, there might be, but right now, do we know a better way? I
So
don't think we
the
do.
slope is 4. Then do that. I
So, Paul, is there a better way? I mean, the answer is normally probably, right? There's probably. Do we know how to do the better way? I don't think. Like, I don't think we have a different way than this. Do you want to talk us through this? All right. So, Nick, what did you do? Because you got there real quick. Aha! She's coming up to take the pen. Aha!
So what I did is I kind of just so if you follow the line and just make it bigger. So I guess
Well, but show the triangles that you showed. Oh, here, I'll change it back to pen.
Yeah.
Come on, these. So up here, yeah. What color do you want?
Purple, green,
Purple.
I told you purple.
Purple.
so you gotta do the growth triangle.
But you're not growing. You're going down.
Okay, so you gotta well they're growth triangles if you're looking at them from the right perspective. You need to think optimistically.
Getting schooled by 7th graders.
Yes, you are.
So you have like 1 and 4 if you repeat the process.
Oh, so we just have to do 2 growth triangles, but backwards. Well, in the negative, in the downward, in the not growth direction. Right, but if we turn around our perspective, it is growth.
Yeah.
And then where do you end up, dude?
You end up
We went down 4 over 1, down 4 over 1.
and you end up at -8.
Any questions? So what does this make our equation? Anybody?
Y equals 4.
4x plus -8.
Either 4x minus 8, may I? Or 4x plus negative 8.
I like 4 plus -8.
Yeah.
No, it's just
That
Brian,
sounds
did
nice.
you just say,
Isaac.
wouldn't the, like, it go over 1 first and then go down 4?
Okay, so now I think I understand.
Yeah,
Right?
like that.
I understand how to
It's
do
in the
this.
same place.
Okay.
You can go either way. It's a great question from Isaac. Growth triangle doesn't matter if you go over, then down, or down, then over. You end up in the same spot.
think about the nature of chess.
Yeah! Yeah, do you know Duke?
No.
I gotta show you this game. It's a variant on chess, and it's way better. I know, that's bold of me to say, because chess is pretty amazing, but Duke is awesome. We are out of time. Clip your papers in. Have a wonderful day, guys. Here, I'll put up a picture of Duke real quick.
Pause the video.